I have to refilm this because it was blurry. Part 238, line 22C, Argon Xenon Propane Compressed Gas Rocket Fuel Fusion 5G Wow Seti. So there's the Wow Seti signal there. Compressed to 150 to 200 ATM theory, compressed gases equals high energy neutrino physics proposal. Neutrinos, argon, propane mixture, rocket power fuel. So the research article is Argon Sensitized Radiolysis of Liquid Propane 1 from R.D. Koob and Larry Keevan from 1966. And there's their stuff here. I'm not going to read it all, but it shows you argon sensitized of liquid propane. Obviously there's something in their formula that you can use with your fuel, okay? The next one is irradiation of xenon, propane and argon propane mixtures with Y rays and 21.2 eV photons from S.G. Lyas, R.E. Robert, and P. Auslus from 1969 again. And mixtures of xenon or argon with propane 21 were irradiated in the presence of radical scavengers by Y rays and by 21.2 eV photons from a helium resonance lamp. The ion pair yields of products originating from ionic fragmentation. Reactions or ion molecule reactions are derived from isotopic analysis of product molecules formed in C3D8, C38H8 mixtures or in CD3CH2, CD3. At a given pressure, there are only small differences between the radiolysis and photolysis in the modes of dissociation of the parent propane ions formed by charge transfer with a particular rare gas. Higher energy ionic fragmentation processes are quenched when the pressure is increased. In the case of xenon propane mixtures, it is demonstrated that the parent ion yield increases as primary fragmentation processes are quenched. In the irradiated argon propane scavenger mixtures, isotope effects on the ionic fragmentation of the excited duration fragment ions are pronounced. The decomposition of neutral propane molecules excited to lower resonance states accounts for not more than 10 to 12% of the product forming processes in the xenon mixtures. 1970, jcp.aip.org. PDF, 320 group VI, a pressurized gas detector for high, iss.fnal.gov, from VK Sharnatyan. ABS-MACF, a new gas detector for high energy neutrino physics, is proposed. The working gas is an argon xenon propane mixture compressed to 150 to 200 ATM. So obviously you want to take a look at this this PDF file and mix it with the formulas that I came up with the argon, xenon, and propane. We did have formulas that came up with those, I believe, in line 19 or 20. Okay. Neutrino Geophysics, Proceedings of Neutrino Sciences, 2005. This is a Google book from Stephen T. Dye. The results of the calculations presented in Table 3 show that a Jovian-like gas envelope is sufficient to compress a protoplanetary alloy plus rock. So June 11th, 2012. Yes, I was doing this recently. It's now June 23rd. So I'm going to Google the keywords gases and argon xenon propane mixture compressed to 150 to 200 ATM. And up comes this PDF file, Gas Supply Systems and Components for Specialty Gases, from elmemesser.lv. This is gases are usually stored, compressed, or liquefied in suitable, and it's got the word argon, butane, chlorine, propane, C12. Test gas without corrosive component. High purity gases and mixtures. Next is the Specialty Gases and Equipment Catalog from weldstar.com. PDF again. As with any chemical or compressed gas, improper use can cause serious. And again, it's got the keywords argon, boron trichloride, boron triuride, butadiene, xenon, total impurities, brass regulators, requested mixture contains a liquefied gas such as propane, the final pressure of. Next is specialty gases equipment catalog for Alliance Gas products, and that's www.alliancegas.com. Another PDF. .tc proper name argon compressed. It's got other keywords: pure gases, a colorless, odorless, non-toxic inert gas Xenon. Technical information: carbon dioxide laser mixtures, 3, 4, and 5 gases. Phosphine, pH3, electronic, propane, and ATM unless other words specified. Chapter 3 of the scribe.com, October 14th, 2008. Air, for example, is a mixture of several gases, but it is often figure 3 to 6 at 1 atm and 20 degrees Celsius. Water exists in the liquid phase. Compressed liquid, it's got temperatures, saturation pressure, passats, various substances, substance, acetylene, ammonia, argon, carbon. Again, keywords came up. Next PDF is automotive PDF, Lind Gases Division, HIQ, Lind, LINDE-gas.com. And it's a PDF. It's specified gas mixtures are used to verify the correct function of the analyzers that are used in the use of compressed natural gas as a fuel is well known and widespread. Typical mixtures contain propane, carbon monoxide, and carbon. Okay, and the solubility of gases and liquids from Ruben Bettino, Lawrence Claver, 1966. That's an oldie. In lieu of an abstract, I&EC research, rapid measurement of gas solubility in liquids using a membrane dispersion microcontactor. There's their names, which I can't pronounce because I think they're Chinese. I probably could, but I'm getting tired here. Energy and fuels from novel physical solvents for selective CO2 capture from fuel gas streams at elevated pressures and temperatures. And there's all the scientists' names that go with that. 2008. I&EC research, solubility of ethylene in the presence of hydrogen in processed solvents under polymerization conditions. Again, there's the scientists' names. 2008 again. Reaction of O2 with the hydrogen atom in water up to 350 degrees Celsius. 2007. And these are from pubs.acs.org. All of those are on the same page, okay? So the 11th of June 2012, I Google compressed Jovian light gas and fuels. Up comes massive Jupiter, www.universetoday.com. 18th of June 2008, would take 318 times Earth's mass to equal Jupiter's. To collect, it would gain mass through the accretion of rocky bodies like asteroids. Fusion requires high temperatures, intense gravitational compression, and fuel. So again, it's talking about fusion there. So June 11th, 2012, line 22C data continues in line 22. Okay, just so you know. Oh, okay, I didn't know that. I told you this only went up to line 22E3. I didn't see the rest of the videos. Line 22 is going all the way from A up to K. So you're going to have to watch all those videos because they all talk about the fuel and the formulas and everything that you need for the UFO thing to go fast, okay? So June 11, 2000. So line 22C data continues in line 22G, H, and I videos. G, H, and I, which have been, I still have to film. Okay. Google search these keywords. See line 22G. Protoplanetary alloy plus rock. Okay, so in each video, these are the keywords that are going to show up in those videos, okay? So line 22G is going to have protoplanetary alloy plus rock. Line 22H is going to be about the Jovian light gas envelope. High energy neutrino physics. Line 22I is protoplanetary gas, and that's called line 22I, protoplanetary gas, circumstellar disk stars, nebular hypothesis, UFO 5G Wow Seti. So that's going to have formulas in it. Line 22K for more keywords from PDF files in line 22C. So basically, I broke it down into smaller sections because these videos get really long. If I do everything on one video, it would take me hours. So I break them down into small segments so that I can make it enjoyable for you, so it's not like, well, some of them are, you know what I mean. It's a lot of dry data, and it gets really boring if you're sitting there listening for 30 minutes. You're going to be falling asleep. Don't want you to do that. I want you to learn from it and use it for whatever it is you're going to make. Okay, so see line 22K for more keywords from PDF files in line 22C. June the 11th, 2012. My thoughts. There we go. There's the formula. Get a pen and paper. These are going to be big formulas. In line 22, I got a lot of formulas. So if you don't feel like writing them down, you can wait till I blog it. And I'm going to probably film all the videos for line 22 before I start blogging it. That way you can go from video to video looking at the formulas and see what you can do with them. Okay? So a new formula idea comes up with the keywords found in line 22C. So we're going to take liquid argon mixed with liquid propane and add neutrinos. We're going to add the UFO 5G previous formulas in lines 17, 18, 19, 20 to 27 plus compressed gas plus. Okay? June the 11th, 2012, I continued this again, as you can see, 2 hours later when I started doing the research. My thoughts. Here's a formula based on all the keywords that stand out here. You want a higher energy ionic plus the Xenon-propane mixtures plus the Argon-propane scavenger mixtures plus the isotope effects plus excited plus deuterated fragment ions plus neutral propane molecules plus excited plus Xenon mixtures. Then you want to take high energy neutrinos, add the gas, plus the Argon Xenon Propane mixture compressed to 150 to 200 ATM, plus the Jovian-like gas envelope plus compress. Line 22C is a mixture of liquid Argon Xenon Propane with excited neutrinos, and then we add a Jovian-like gas and compress it. I'll Google the keywords to see if this will work, or if someone's tested these key elements together and find a mixture solution for you to try. June the 11th, 2012 at 12:29 p.m. My thoughts as I read this data from the massive Jupiter. Keyword is fusion. Fusion requires high temperatures, intense gravitational compression, and fuel. So we'll take a formula here. We'll take fusion, we'll add high temperatures, we'll add intense gravitational, and add compression, and then add fuel. June the 11th, 2012 at 12:57 p.m. My thoughts. I'm going to look at keywords that have been mentioned before in previous lines of data from lines 1 to 22 up to June the 11th, 2012. I'm going to research and mash them together to see what I can come up with for you to try. I look at words that stand out to me and put them in each equation as I go through the data that comes up. All Google searches will be put in line 22K videos. Formula ideas from keywords found in links in the PDF file descriptions are as follows. So what I do is I take the keywords and I add them together, and then we'll see if they make anything, or if they make any sense, or if they don't make sense, you might have to add something to it to make it work, okay? So you can take the calculations. So in this case, when I say calculations, there are a lot of math equations provided in the WOW signal. When we go through the cross-referencing, I'll be putting the different math equations that you're supposed to use together. So basically, they give you instructions of inventions and PDF files and stuff, and you take the keywords, you put it together, and then you add your calculations from whatever math equations come up in those videos. You use those math equations to make your calculations to make the formulas from the keywords. That's what it basically means. So the calculations plus the Jovian-like gas envelope plus compress plus protoplanetary LA plus dash rock plus neutrino plus geophysics. Next is the gases plus the stored compressed plus liquefied plus argon plus AR 200-300 plus butane plus C4H10 plus chlorine plus C12 plus TC plus propane plus C3H8 plus gas to corrosive component plus max 200 plus high gas purity gases plus mixtures plus 300 bar plus Elmiser. WeldStar plus chemical. So when I say WeldStar, Elmiser, that's obviously you go to their website and see what kind of components that you can use from them in your UFO. Okay. WeldStar plus chemical plus compressed gas plus argon plus boron trichloride plus butadiene plus Exxon plus brass regulator plus mixture plus liquefied gas plus propane plus pressure. So I'm going to Google boron trichloride because I don't know what it is. And I'll be Google butadiene to find out what that is too. And then I have argon plus compressed plus pure gases plus Exxon plus carbon dioxide laser mixtures plus 3, 4, and 5 gases plus phosphine plus pH3 plus electronic plus propane plus C3H8 plus 70 degrees Fahrenheit plus 1 ATM plus alliance gas products. Google pH3, Google C3H8, Google 1 ATM, Google carbon dioxide laser mixtures, gases plus 20 degrees Celsius water, compressed liquid, plus saturated pressure, it's 20 degrees water plus the compressed liquid, plus saturation pressure plus acetylene ammonia, argon, carbon. I'm going to Google acetylene ammonia, argon, carbon to find out what it is. Then compressed natural gas plus fuel plus propane plus carbon monoxide plus carbon ? Plus argon plus solubility plus gases plus liquids plus measurement plus soluble liquids plus membrane dispersion microcontactor. Google membrane dispersion microcontactor. CO2 capture plus fuel plus gas plus elevated pressures plus temperatures plus soluble ethylene plus hydrogen plus polymerization plus reaction plus hydrogen atom plus water at 350 degrees. Total all the formulas together from line 22C and you get this. And then again, I'm not going to read it all together, but what it basically is put all these little formulas together into one big long formula, okay? And when I blog it, you'll be able to see it all. So I'm just putting it all together to see. These are all the formulas from 22C, line 22C. And all it is basic keywords that came up in the PDF files. Okay? So the 11th of June 2012 at 1:09 p.m. These Google searches from keywords in line 22C will be in line 22K videos. So I've moved all these Google searches from this video in 22C, and you can either jump to 22K or I wouldn't do that. I would just make a note of it, that's where the Google stuff is. And you want to watch actually lines 22A all the way to K because they're all connected together. These Google searches from keywords in line 22C will be in line 22K videos. I want to know what they mean. If lots of data comes up, then they will go into the line 22L. So basically, I haven't done the research yet, sorry. Line 22E4, I start my next research, so I don't even know if these videos might go longer than L, based on how long-winded they get to be. So just stay tuned, that might change, okay? If more keywords come up, then I'll have to add them into the formulas for line 22C. So I'll be Googling pH3, Google C3H8, Google 1 ATM, Google, okay, now I'm just making a list of all the Googles I'm going to be doing in K and thereafter, okay? Find out what comes up with them. So deuterated fragment ions, I will research and film this data in line K and L videos and so on. So basically, if I've got too much data after L, I'll go to L, M, all the way to Z, okay? Sorry, 19 minutes.